2 of our review on sequences and series. Find D for this sequence. For finding D for a sequence, we've only got one option. We're using this arithmetic sequence formula right here. So we know a sub 14 is negative 97, so that goes in for a sub n. A1, negative 6. D, so plus D, times n is 14 minus 1. So we can add 6, and we get negative 91 equals 13D. So negative 91 divided by 13, and we get negative 7D is negative 7. Find the sum. When we're finding a sum, it's one of these. The first 25 terms, this is for an infinite number of terms, so we're down to just these two options here, arithmetic or geometric. It looks like we're adding 4 each time, so we've got a common difference of 4. So we're using the arithmetic formula. Sum of the first 25 terms is n, 25, over 2, times the first term, negative 12, plus the last term, which we don't know yet. So anytime we use this formula, we need to use the one right above it as well. We have to find a sub 25 to go in this last spot. So that is the first term plus the common difference times n minus 1. So that's negative 12 plus 4 times 24. And that last term has a value of 84. So now we can do 25 over 2 times negative 12 plus 84. And we get a sum of 900. Find the next 3 terms in this arithmetic sequence. So it's arithmetic, so I know there is a common difference. Negative 13 minus negative 5, and that equals negative 8. So I know that we are subtracting 8 each time. Negative 13 minus 8, minus 8, minus 8. And those are my next 3 terms. Negative 21, negative 29, negative 37. Find n in a geometric sequence. That means we're going to be using this formula right here. It's geometric, and it's not a sum, so that's my only option. So a sub n is 1.5625, and that equals a1, which is 2.5. Sorry, it's 25. Times r, which is 0.25, to the n minus 1 power, and we don't know n. We can divide both sides by 25, so 1.5625 divided by 25 is 0.0625. And that equals 0.25 to the n minus 1 power. I can put that in log form. The base is 0.25. The argument is 0.0625. And that equals the exponent n minus 1. So if I do log of the argument divided by log of the base, and then I need to bring that 1 over, so plus 1, that's going to give me n. So log 0.0625 divided by log 0.25, that's 2, plus 1 is 3. Find n in an arithmetic sequence. That's going to be our top left formula. A sub n is 7 equals A1, which is negative 13, plus D times n minus 1. So I can add that 13, I get 20 equals 4n minus 4, so I distribute it. Add that 4, 24 equals 4n, and 24 divided by 4 is 6. And then find the fourth term of a geometric sequence. So for the fourth term of a geometric sequence, we're looking for a sub 4. That equals the first term times r to the n minus 1 power. So that's 7 times negative 6 to the third power. Negative 1,512.